Since EASy's introduction, Dassault and Honeywell have been working to develop new features and capabilities to provide operators with the most advanced technology. Well, it's here now, and it's called EASy II. EASy II is both a software and hardware upgrade which is available for both new production and in-service aircraft. EASy II comprises a baseline service bulletin and 8 optional service bulletins. The baseline service bulletin includes several new features and is a prerequisite to comply with any of the optional service bulletins. The significant benefits of EASy II are improved safety and situational awareness, enhanced navigation capabilities, superior surveillance capabilities, and mandate compliance. One of the key features of EASy II's baseline upgrade is the new and improved primary flight display. Unique improvements now incorporated into the EASy II baseline PFD include a full-scale horizon line, an uncaged flight path vector, an expanded pitch scale and ADI, additional HUD-like free-floating flight path symbology, and a new final approach glide angle reference cue. The new PFD provides commonality with the HUD, improving head-up and head-down transitions for the pilot, enhanced crosswind awareness at low altitude, and is designed to be conformal with the synthetic vision option. Additional features included with the EASy II Baseline 2 upgrade include Smart Runway RAS, which is Runway Awareness and Advisory System, which proactively addresses the NTSB's number 2 initiative to improve runway safety, RNP AR 0.3, which improves access to airports and airspace while increasing operation efficiencies, a new advanced takeoff and go-around mode, second electronic checklist for added redundancy, and several new FMS capabilities like Baro VNAV temperature compensation and circling approaches. The new satellite-based augmentation systems complement existing GPS information and increases their integrity and accuracy, allowing GPS to be used as primary navigation information during critical phases of flight, like during a final approach. Additionally, the higher integrity and availability means predictive RAIM is no longer required. It also increases the number of accessible airports in adverse weather conditions and is fully compliant with emerging ADS-B requirements. This new augmentation signal can only be received by upgraded GPS systems, better known as SBAS GPS. Satellite-based augmentation systems are already in operation in Northern and Central America called WAAS, and over Europe called EGNOS, with more to follow in other regions around the world. LPV approaches are ILS-like approaches which rely on SBAS GPS guidance to provide a straight-in continuous descent final approach with decision altitudes down to 200 feet above the runway near ILS Cat 1 minimums. All this without any need for an ILS. There are now more LPV approaches in the US than ILS Cat 1 approaches, and more than 60 LPV approaches in Europe, with more waiting to be published. The LPV approaches option offers new landing options in challenging weather and at airports with limited infrastructure. EASy II's ADS-B out option provides improvements to the existing transponder and relies on the included SBAS GPS to provide specific aircraft and position data to air traffic control with significantly more accuracy than standard radar positioning provides today. This allows improved aircraft tracking by air traffic control, leading to a more efficient use of airspace. ADS-B out-equipped aircraft are already experiencing routing advantages in some regions and are compliant to the rest of the rapidly approaching worldwide ADS-B out mandates. Honeywell's award-winning Smart View synthetic vision option adds an advisory display of 3D terrain to EASy II's improved baseline PFD, significantly enhancing the crew's situational awareness. By coupling HUD symbology with the most advanced 3D terrain representation, including obstacles, runways, grid lines, range rings, and extended runway center lines, the flight crew has significantly clearer visual understanding of their flight path and interaction with the surrounding terrain. EASy EASy II's automatic descent mode option adds an additional safety feature by initiating an automatic descent to a safe altitude in case of depressurization at high altitudes. In the case of a rapid depressurization, the time of useful consciousness at 40,000 feet is 5 to 10 seconds. During this critical situation, ADM greatly reduces the crew's workload as the autopilot and auto throttle automatically guide the aircraft to a safe altitude at maximum velocity. ADM is activated when the autopilot is engaged, the aircraft is above 30,000 feet, and the cabin altitude is 9,700 feet or greater. When ADM is activated and a rapid depressurization is detected, the aircraft will automatically make a 90-degree left turn while the auto throttle auto-engages and, if required, reduces the thrust to idle. The aircraft will then continue its auto descent at a speed of 10 knots less than VMO-MMO. Simultaneously, 15,000 feet is automatically set as the pre-selected altitude and ADM is enunciated in the center of the FMA panel. Upon reaching 15,000 feet, the aircraft automatically levels off and maintains 250 knots. ADM remains active until the autopilot is disengaged. The dual Jeppesen charts option provides redundancy for the use of the electronic charts. Instead of being stored in a single remote data storage, this option allows the database to be hosted on each of the 4 advanced graphics modules, providing 4 independent sources of the data. This facilitates a noticeable improvement in the speed at which the charts are accessed and rendered on the display. This option provides uplinked graphical weather information broadcasted by XM to be overlaid on iNav. XM's advanced digital satellite broadcast infrastructure provides the optimum method of transmitting the XM satellite weather data to aircraft flying anywhere within the contiguous United States and coastal waters. XM's advanced technology allows for dependable reception of the XM signal in all weather conditions and features affordable, unlimited use subscription plans and wide-ranging display options. It provides the crew with the necessary weather information to optimize the route according to operational constraints in terms of comfort, safety, fuel consumption, and arrival time. Information is automatically updated and stored until requested by the pilot for display. The last 2 options are the data link communications options. Simply stated, controller-pilot data link communication is text messaging between the pilot and ATC for aircraft control instead of using voice communication. Pilots can request and/or acknowledge changes to aircraft speed, altitude, and route using standard ATC phraseology. The data link functionality is hosted in the modular avionics unit on the flight management and comm management modules. The pilot interface to the system is via the MCDU and a new ATC Data Link 1/6 window displayed in either the primary display unit or the multifunction display unit, selectable by the flight crew. CPDLC utilizes both SATCOM and VHF data links. FANS has been in service with airliners for over 15 years in oceanic regions. The benefits available now to operators selecting this EASy II option include fewer delays on the ground while awaiting clearance, route clearances automatically made in flight plan, capability for the flight crew review and print clearances, preferred more direct oceanic routing, fully automated oceanic position reporting via ADSC, increased safety through improved controller awareness of aircraft position, better oceanic communications, no more noisy and congested HF, and reduction in errors between pilots and controllers. CPDLC is language agnostic, as most messages are canned and included within the system, greatly facilitating those operators who may not have a very high comfort level with the English language and can rely upon this as a tool to accurately communicate quickly and easily. The EASy II ATN B1 data link option meets pending European airspace requirements, and more specifically, the PM-CPDLC mandate for flight level 285 and above, which is scheduled to go into effect on February 5, 2015. The ATN B1 data link uses a more recent ATN network and protocol, which in turn requires the use of a newer type of data link called VHF Mode 2. The VHF Mode 2 data link improves data integrity through end-to-end message checksum. The intent of the PM-CPDLC mandate is to reduce the saturation of VHF frequencies over Europe. The EASy II upgrade from Honeywell and Dassault, available now for all EASy flight decks.